Hello guys, and this is the review for exam 1, question 1 on searching a linked list. Now, we start with, there are 3 parts to this question. If you have a linked list with 80 words in random order, and searching it was successful 60% of the time, what is the average number of comparisons to search the list? So, this is one of the simpler ones. Okay, so the idea is with then the next part is going to be what the same question but with a sorted linked list. So this is an unsorted linked list. They're in random order. This is a sorted linked list. And then the final part is if your linked list had 10 of 80 words 25% of the time, so this is a cached one. The first 10 words are a lot more likely than the last 70. So let's focus on question 1 first of all. Okay, so 40% of the time, if the word is not in the list, you have to search the whole list to discover that. So we're going to have 0.4 times 80. Okay, or we can say 1 minus 0.6 times 80. Okay, so those are the guys who are not in the list. You have to search the whole list to discover that. Now that's going to be different with the sorted. Now, then the other 60% of the time, so 0.6 of the time, it's equally likely from 1 to 80. So the average search is going to be 1 plus 80 over 2. And then the arithmetic for that is going to be, oh come on, times 1 plus 80 over 2. This guy is a little bit of a stickler for putting in those multiplication signs. And that's going to be 56.3, and that's the answer to part A. Okay. Now part B. The difference with a sorted list is a sorted list, part B, is going to, it can stop early. So in the 40% of the time, it can end up searching 1, 2, 3, 4, 5, 6, 7, up to 80 searches with equal probability. Right? Why are they equal probability? Of course, let's say we did 1,000 searches or something. And so you take 1,000 words that you're searching for, and you scramble them up in a permutation. Just all over the place. And now, you got the scrambled words, and some of them are going to be among the 80 will be the 80 words that actually made it in the list, and the rest of the 1,000 words, okay? Well, basically, on average, you'll have equal proportions before the first word, second, third, fourth. There might be a little more, but I don't want to do the math of it. So I'm just going to assume equally likely to hit all of those. So what are we going to do then? Then we're just going to do 1 plus 80 over 2. 40.5. And you don't need to say this, but that's going to be 15.8 faster, or 15.8 divided, 15.8, 15.8, yeah. 15.8 divided by 56.3 equals. Okay, so that's 0.28, or, right, times 100, 28.6% faster. Okay, these are not required, but they're sort of nice to know. So sorting the list gives us a little more than 25% faster, right? 28% faster. Now, let's create a cache for this. So normally, so the first 10 are 25% at a time. Now in this thing, the first 10 were 1/8 of 60% of the time, which is about 7.5%. So this is, instead of the first 10 being 7.5% of the time, its first 10 are 25% of the time. So that shortens the searching time. So that's going to mean, now they're all equally likely to, so if it's one of the first 10, you're equally likely to find it. So 25% of the time, or 0.25 times 1 plus 10 over 2 will be the amount you spend when the word is one of the first 10. Okay, so we've moved the more likely candidates to the beginning of the list, making it easier to search it. Now the next 70 are 35% of the time. So those will be positions 11. So you'll do 11 searches to find whether it's in the next 10. So you'll have to do 11, 12, 13, 14, 15, up to 80 searches. So we have 0.35 of the time. 0.35 of the time. We're going to do either 11, 12, on average 11 plus 80 over 2. And finally, okay, that's 60% of the time, just like in question A, it's 60%, only the order of the words have been rearranged so that the likely words are at the beginning. Now, the other 40% of the time, just like in question 1, and my face is over question 1, there it is. The other 40% of the time, it's going to take 80 searches to discover they're not in the list. So 0.4 times 80. And that's going to equal 49.3. So, not as fast as the sorted list, because the sorted list gives us that big advantage in the 40% of the time, but significantly faster. 7 faster on average than the totally unsorted list. And that's the answer to question 1.